All right, guys. What we're talking about today is arc and arc measures. We're going to start off with arc and arc measures. Now, there's three types of arc measures, or classifications of arc measures that we can have. We have minor arcs, major arcs, and semicircles. Now, a minor arc is going to be an arc with a degree measured less than 180. A major arc is going to be one that has an arc measure greater than 180. And if the two endpoints of an arc connect to the diameter, it will be exactly 180 degrees. So if ABC, the central angle, is less than 180, then the points on C that lie in the intersection of ABC are a minor arc. If it's greater than 180, it's a major. And if it connects to the endpoints of the diameter, it is exactly 180. So here's a little bit more specific definition. So the measure of a minor arc is the measure of the central angle. The central angle is an angle whose vertex is on the center of the circle, and its measure will be the same as the arc. So since the central angle here, ACB, is 50 degrees, its arc measure is 50 degrees. Now, since an entire circle is 360, ADB is going to be 310. Now, whenever we're wanting to say an arc measure, you either use 2 or 3 letters. Whenever we're using 2 letters, we're always talking about the shortest distance. The shortest distance between those 2 points along the arc. If it is greater than 180, we're going to use 3. First letter is going to be the starting point. The middle letter is where we're going through. And the last letter is where we end. So when we talk about measure of arc, ADB, we're starting at A, going through D, and finishing at B. If there's more than one letter, we only use 3. So even if we had points E and F, ADB would still be describing the same thing. We could also have described it, if we had these extra points, as the measure of arc AEB, or the measure of arc AFB, because that middle letter is just telling us where it's going through. It kind of gives us a direction for where we're going. So to start off with, we're going to find the measure of each arc on circle P, where RT is the diameter. So we're looking at this here to start off with. We want to find the measure of arc RS, starting at R and going to S. This is going to be our first arc. Now, what would the measure of this arc be? It would be 110 degrees, because the arc measure is the same as its central angle. And the central angle for this arc is 110 degrees. Let's look at the next one. We want to find the measure of arc RTS. So here we're starting at R, going through T, and ending up at S. So it's going to be greater than 180 because we do have the diameter. RT is the diameter, which would be 180 degrees. So this here is 180 degrees. So we know we're going past that, but we're not including the 110. So we have everything except for the 110 degrees. Exactly. So what we can do is I can take the whole, which is what? 360 degrees, and subtract the one part we're not including. Because we're not including that 110, yes? So I can subtract these two. 0, 6 minus 1 is 5, 3 minus 1 is 2. So the measure of this arc is 250 degrees. Any questions on either one of these here? Let's look at the last one. R, ST, because R and T are connected to the diameter, This would be exactly 180 degrees. Any questions on this here? All right, let's look at some more of these. So we'll do 3 more of these here. So if we're looking at this here, we want to find the measure of AD. Because AD will be the same as its central angle, and since the central angle is 65 degrees, its arc measure in degrees would be 65 degrees. Now the next one we're looking at is DAB. DAB. So what are we including? DAB. So we have the 65, and we know that this here is what? So it included the 180 because it included the diameter, the arc that has the diameter. Now, is the 65 included in this arc? So this time we wouldn't subtract 65 from 180. We would do what? To what? We would add it to 180 because it's including the diameter, the section we know that is 180, with 65. So we'd have 5, 8 plus 6 would be 4, carry the 1. So DAB, the measure of arc DAB, is 245 degrees. Any questions on how we found this one here? And last but not least, we want to find DB or BDA. Well, that'd be 180 degrees because BDA is connecting the 2 ends of the diameter. So it would be 180. Yeah, it's half the circle. The diameter would be half the circle. Now, is this telling me anything about the actual measure of AD or B or DAB or BDA? No, because it's all based off the fact that a circle is 360 degrees. Now, the measure of an arc formed by 2 adjacent arcs is the sum of the 2 arcs. We can add any 2 arcs together. I can add AB to BC and get the measure of arc ABC. It's just our line segment addition property. So if I look at this here, if I want to find GE, we only use 2 letters, so we're finding the shortest distance from G to E. Somebody going from here to? Right. So we have those 2 arcs. Now we have 2 central angles. So GH is going to be 40. HE is going to be 80. So to find GE, we're going to do 40 plus 80, which gives us 120. We're going to add those 2 together. Any questions on this here so far? All right, let's look at the next one, GEF. Starting at G, going through E to F. Now we know this is 40, this is 80. Well, FE is going to be 110, or EF. So we can add these together, 110 plus 40 plus 80 to get our overall answer. And if we add those 3 together, we should get to 30. And then last but not least, we want to find GF. Well, how could I find GF? Yes. Since I know everything else is 230, I can subtract it from 360 to see that GF is 130 degrees. Any questions on any of this here? Are we good with this here? Yes? Okay. Let's look at one more. This one here is a little bit of an application, but I have a feeling you'll feel comfortable with these here, yes? So, a recent survey asked teenagers whether they would rather meet a famous musician, athlete, actor, inventor, or other person. The circle graph shows the results. Find the indicated arc measures. So, we're looking at this here, so we want to find A, C. How many want to meet an inventor or a musician? So what would we do to find that? So we do 108 plus 29. 137 degrees. Well, how about ACD? So, right, since we know what inventors and musicians already added together is 137, well, we can add to it athletes, which is 83. 7 to 3 is 0, carry the 1. 9, 2, carry the 1. And do we all agree with 220? And we get this one here. The next one, measure of ADC. ADC. So we're going the other way around. To 61 and 83. Yes. Because since we know that the only two that weren't included, which was musicians and inventors, so we can do 360 minus 137. 5, 3, 2, and y'all got 223. And last but not least, EBD. EBD. Right, we can do 360 minus 61. 299. And that would be that one there. Any questions on any of these here? Okay, good. Do we feel comfortable with these here? Yes? I think so. All right. If we feel comfortable. Yep. Let's look at these three here because there's a second part to it I want to make sure y'all get, because finding the measures I know you feel comfortable with. Yes? So QS, so read the instructions. QS, what would QS be? So QS would be going from Q to S. So we don't know what SR is. Yes. So what we could do first is we can take 120, 80, and 60 and add these together. Well, that's 0. 8 and 2 is 10, which leaves me with 6, so I get 260. So STR or SQR is 260, yes? And what we can do is we can subtract this from 360, which gives us, so the measure of SR is 100, which helps us because now I can find QS by adding 100 to 60, which gives me what? Yes. Which would give us 160 degrees. Yes? Okay. So, the answer for number 4 is 160. Yes, and we're finished with number 4. Yes.
So how do you know if it doesn't give you a middle letter? How do you know what to repeat?
It's always going to be the shortest distance.
If it's 2 letters.
If it's 2 letters, we're always going the shortest path.
Is this one of those things where you can check it by like adding all 4 of them together?
Yeah.
It's 360.
Right, because all of these here will always add together to be 360 degrees. So 100, because if we add 120 and 60, that would be 180. 80 plus 100 is 180, and 180 and 180 would give us 360. So it always will add up to be 360. And if we said any kind of TR, really anything past TR in either direction will be the shortest distance, because TR is the diameter. So whenever we use 2 letters, we're always going the shortest path to get there. So we said QS, it's on that borderline, because anything really at midpoint at the 180 mark or greater, you're going to need 3. Because as soon as we get past that, you're going to go the shortest way, you're going the other route. Okay? So is that all we needed to do for number 4? Yes. And how do we know it's a minor arc?
Less than a half circle.
Less than a half a circle, which is less than 180. If it's less than 180, it is a minor arc. And how about TS? Would be 80. And this would also be a minor arc. And lastly, RST is 180. It is a semicircle. A semicircle. And that's all we need to do for these here. And if it's major, it is greater than 180. Congruent circles theorem. There's 2 parts of this. 1, if two circles are congruent if and only if they have the same radius. 2 circles are congruent if and only if they have the same radius. Or if they have the same diameter. But if they have the same diameter, it means they have the same radius. Now, in the same circle or in congruent circles, 2 minor arcs are congruent if and only if their corresponding angles are congruent. So if the corresponding angles are congruent in 2 circles or in the same circle, then their arcs are congruent because the arc measure is the same as its central angle. So, looking at this here, are the 2 red arcs, it's hard to see on your paper, but on this here, are the 2 red arcs congruent?
Yes.
Because their Their angles are congruent. Their scribed angles are congruent. I don't know why I lost the word inscribed there for a second. Because the inscribed angle for each one of those arcs are congruent, it means the arcs themselves are congruent as well. Any questions on this here? Are these two red arcs congruent?
Yes.
Because are the inscribed angles congruent? They're both 90 degrees, yes? Are the circles congruent? They're not. They are, one is bigger than the other, yes? They do share the same center. Let's see here. If they share the same center, they are concentric circles, or one's bigger than the other. So are the red arcs congruent? No. Because the CIRC circles aren't congruent. The circles are not congruent. They could have the same arc measure, but they're not congruent to each other because these are concentric circles. Questions on this here? Now, can we say that these two here are congruent? I would agree, yes. Why? The circles are congruent and so are their corresponding central angles. That's what I was looking for, not inscribed. Central angles. Used the wrong word earlier. It wasn't inscribed on the other one. Inscribed's not, it's on the circle, not at the center. And I'll go fix that here in a second. But are there questions on this here? Okay. What I was saying a minute ago is this here should not be inscribed. It should be central. I don't know why I forgot. Flip those two. Central angle, central in the middle. Angle formed in the middle. Inscribed is on the circle. Yes or no? Are these two congruent? No. No. Because the circles are not the same. They're not congruent. Now, what do I know about the line SP? It's the diameter because it goes all the way across and goes through the center. Since T is the center of the circle, it is the diameter, which means this here is, the other one is 180, yes? So if I add 65 and 50, I get 115. we can subtract it from 180. So they're in the same circle and they have the same central angle. So are the two arcs congruent? Yes. Yes, they are. Any questions on this here? All right. Similar circles theorem. This is the last thing we're going to cover. So are there any questions on this here before we cover similar circles? Does anybody have a guess at what similar circles theorem is going to be? Circles that are similar? How many circles can we have that are similar? All of them are. Because really, what do we do when we make a circle? It has a center and a radius, yes? We're either making the radius bigger or, because there's no other way we can make a circle. Because as soon as we start changing the shape like this here, it's not a circle, it's an oval. So all circles are similar to each other. Which this is. Yeah. Let's see here. Be helpful if I can write. Not bad.
Circle.
I'd say pretty close.